Ya, Assalamualaikum warahmatullahi wabarakatuh. Selamat siang, salam sejahtera buat kita semua, Bapak, Ibu, dan peserta semuanya. Terima kasih sudah hadir kembali bersama kami dalam rangkaian kegiatan webinar series bersama oleh. Kali ini kita akan berbicara atau membahas tentang PLANBAR yang berkaitan dengan Precast. Nah, Bapak Ibu semua, mohon izin, ini saya mewakili Bapak Kepala Balai Penerapan Teknologi Konstruksi, Bapak Cakranagara, karena beliau ada penugasan yang lain, jadi beliau meminta saya untuk mewakili menyampaikan materi. Nah, ini mungkin materinya Bapak Ibu kebanyakan mungkin sudah sudah sering lihat itu, sudah sering karena sudah beberapa kali kita kegiatan sama pandemi ini sudah berkali-kali ya kegiatannya dan disampaikan materi ini berkali-kali, tapi mohon izin saya tetap harus menyampaikan ini amanah dari Bapak Kepala Balai Penerapan Teknologi Konstruksi. Sebentar, oke, ini saya share screen dulu. Could you please, okay, share screen, okay. Ya, jadi Bapak Ibu semua, ini kami dari Balai Penerapan Teknologi Konstruksi, Direktorat Jenderal Bina Konstruksi Kementerian PUPR. Kami memang secara regulasi menurut Undang-Undang Jasa Konstruksi Nomor 2 Tahun 2017, kemudian juga peraturan-peraturan turunannya, dan juga peraturan Presiden dan peraturan Menteri tentang tugas dan fungsi dari kami, memang kami ini intinya adalah sebagai pembina konstruksi di Indonesia, baik itu membina orangnya, membina badan usahanya, teknologinya, material, dan seterusnya. Jadi kami memang berkaitan dengan pembinaan konstruksi. Nah, Bapak Ibu, sebagai informasi bahwa Indonesia ini kita pasar konstruksinya sangat besar di Asia dan juga di ASEAN nomor 1, tapi sayangnya ini peringkat daya saing infrastruktur kita menurut World Economic Forum kita jebloknya ada 52 ke 71. Ini ada kaitannya juga dengan kesiapan teknologi, dengan adopsi teknologi yang kita lakukan gitu ya di Indonesia, khususnya untuk sektor konstruksi. Ini menjadi PR tersendiri. Padahal pasar konstruksi kita sangat-sangat. Nah, Bapak Ibu, solusi berikutnya adalah badan usaha. Badan usaha di Indonesia ini banyak banget, ada 140 lebih, tapi 80% itu masih kecil. Padahal kalau untuk proyek-proyek konstruksi ini kan sudah sangat masif, sangat banyak, dan proyeknya gede-gede ya. Kalau di Indonesia ini udah banyak banget. Nah, kalau misalkan lebih banyak yang kecil, ini sangat kecil nggak apa-apa sih banyak, tapi kalau misalkan yang besar-besarnya ini angkanya tidak terlalu signifikan, ini maka juga menjadi PR sendiri bagi kami supaya gimana kita berharap sih badan usaha itu besar-besar. Karena kenapa? Karena kalau badan usaha besar itu artinya dia teknologinya menggunakan advance, SDM-nya juga advance, modalnya gede dan seterusnya. Nah, ini karena kan untuk mengerjakan proyek-proyek yang kompleks, yang advance gitu ya, yang besar nilai proyeknya itu tentunya diperlukan perusahaan-perusahaan besar. Ini juga salah satu concern kami, gimana caranya kecil, menengah, besar semuanya bisa bertumbuh gitu ya. Ya, bahkan nanti bisa ekspansi ke luar negeri. Sebenarnya kalau yang udah ekspansi udah ada sih beberapa perusahaan ya. Tapi kita berharap lebih banyak lagi yang bisa ekspansi ke seluruh dunia gitu ya. Baik, kemudian isu berikutnya berkaitan dengan tenaga kerja konstruksi. Nah, ini untuk tenaga kerja konstruksi ada tren penurunan tenaga ahli muda yang bersertifikat sejak tahun 2015 sebesar 3% per tahun. Nah, jadi piramidanya ini tidak ideal. Harusnya kan piramidanya ini paling bawah ini paling banyak, ahli muda paling banyak, ahli madya, kemudian ahli utama. Nah, tapi ini kok malah yang ahli mudanya menurun. Ada apa? Gitu ya. Yang ternyata ini ada kaitannya dengan godaan, tanda kutip ya, godaan dari banyak sekali jenis pekerjaan lainnya yang memang gajinya lebih gede, gitu ya, lebih tertarik, lebih menarik. Kemudian juga selain itu, karena memang asas-asas kesempatan yang diberikan untuk mereka bisa bertumbuh di bidang konstruksi, misalkan kesempatan pelatihan, sertifikasi, magang, dan sebagainya itu masih kurang begitu banyak akses yang diberikan. Nah, kami dari Dijen Bidang Konstruksi melakukan terobosan-terobosan tersebut supaya bagaimana bisa diakses oleh seluruh masyarakat secara gratis, secara murah, gitu ya, gampang, dan menumbuhkan minat orang-orang untuk bisa stay bekerja di bidang konstruksi. Bapak Ibu semuanya, ini slide berikutnya tentang lingkungan strategis SDM konstruksi. Nah, di sini ada bulet-buletan dan kotak-kotak. Intinya adalah kata kunci berkaitan dengan sertifikasi, standarisasi, standar dan sertifikat. Ini untuk apa? Ini untuk penjaminan mutu, untuk supaya jaminan mutunya bisa terjaga gitu ya. Karena kan dibuktikannya dengan standar dan juga sertifikasi. Apa saja yang disandari dan sertifikasi? Ya orangnya, ya manajemennya, ya materialnya, ya peralatannya, ya alat uji cobanya, dan seterusnya, dan seterusnya. Semuanya sekarang eranya adalah standar, sertifikasi. Karena apa? Karena kita dituntut di zaman yang serba cepat. Apalagi di zaman revolusi industri 4.0 ini, segala sesuatunya itu sangat-sangat real time gitu ya. Lalu lintas data dan seterusnya itu benar-benar sangat-sangat cepat sekali. Dunia sudah seperti tidak ada batasnya lagi. Gitu ya. Jadi apalagi di bidang konstruksi juga dituntut untuk cepat, karena permintaannya seperti itu, kebutuhannya seperti itu gitu ya. Jadi di mana ini juga pengen cepat. Salah satu untuk supaya cepat bisa dilaksanakan tapi juga tetap terjaga mutunya, kualitasnya adalah dengan adanya standarisasi sertifikasi untuk menjaga mutunya tetap terjaga. Nah, ini strategi yang kami lakukan khususnya dari Balai Penerapan Teknologi Konstruksi, Direktorat Jenderal Bidang Konstruksi. Dengan PUPR kita ada 3 strategi. Yang pertama yaitu melakukan distance learning Sibima konstruksi. Di sini adalah pelatihan online melalui website sibima.pu.go.id. Di situ nanti pilihan-pilihan ganda soalnya. Nah, ini merujuk kepada SKKNI materi-materinya. SKKNI itu apa? Standar Kompetensi Kerja Nasional Indonesia. Jadi di situ kita anggap sebagai basic atau dasar untuk seseorang itu. Kalau misalnya lulus itu berarti dia sudah minimal banget, sudah oke lah gitu ya secara kompetensi bidang konstruksi. Nanti ada macam-macam di situ jabatan kerjanya, nanti bisa silakan dilihat ya di website kami di sibima.id. Kemudian strategi berikutnya adalah berkaitan dengan BIM. Kenapa kami ini membina tentang BIM ini? Karena ini bagian dari hal yang memang ya, karena kami pertama namanya juga Balai Penerapan Teknologi ya, teknologi. Jadi BIM ini teknologi yang memang untuk mempercepat, mempermudah kinerja pelaksanaan, khususnya pelaksanaan ya proyek konstruksi gitu. Nah, nanti apa saja strateginya? Di antaranya adalah kegiatan-kegiatan seperti ini, melakukan pembinaan SDM melalui webinar, pelatihan, dan seterusnya. Yang ketiga, strateginya apa? Strategi itu adalah magang konstruksi. Nah, ini kami melalui surat edaran Menteri PUPR nomor 23 tahun 2019. Di situ dinyatakan, jadi ada regulasi teknisnya tentang memberikan kesempatan bagi mahasiswa atau fresh graduate untuk bisa magang di proyek konstruksinya PUPR yang di atas 50 miliar. Nanti silakan dibaca-baca aja peraturannya ya. Intinya kita memberikan akses gitu untuk magang. Jadi ini semua untuk terobosan-terobosan untuk menjawab kekhawatiran, kegundahan ataupun kebutuhan memang yang di masyarakat khususnya untuk generasi muda. Nah, Bapak Ibu semua, mengapa BIM diperlukan? Ya karena BIM ini kan kaitannya dengan data digital ya, dan sekarang eranya sudah digital semua, jadi ya mau nggak mau kita harus ke arah situ gitu ya, ke arah sini semuanya menggunakan digital. Karena seperti Bapak Ibu ketahui, apalagi yang aktif di proyek gitu ya, yang berkiprah di proyek pasti ngerti, pengarsipan proyek itu mungkin masih belum terlalu rapi. Kadang file itu disimpan di email, kadang disimpan di WhatsApp, kadang disimpannya di Dropbox, kadang di Google Drive dan seterusnya. Mencar-mencar, masih belum terlalu baik gitu ya pengarsipan-pengarsipannya. Dan mending itu kalau digital ya, masih bisa dicari-cari, nanti di search, control find dapat. Tapi kalau misalkan itu filenya paper based gitu kan, itu wah banget banget kalau naruh di mana, ditaruh di mana, hilang, basah, rusak ya, hancur, jamuran dan sebagainya itu. Nah, sehingga BIM ini juga kaitannya kalau digital, dia jadi bisa menjadi database perencanaan, apalagi perencanaannya supaya proyek itu lebih terintegrasi. Nah, ini kaitannya juga nanti dia akan bisa mengatasi masalah-masalah inefisiensi dan inefektivitas dari proyek. Nah, permasalahan yang akan datang apa? Permasalahan yang akan datang ini masih pekerjaan sekarang makin kompleks, makin bangunan-bangunan itu makin sophisticated, ya, makin rumit, berliuk-liuk dan seterusnya. Bahkan di masa pandemi COVID ini juga bangun apa rumah sakit harus dalam waktu yang singkat. Gitu. Kalau misalkan pernah lihat video yang sempat viral itu di Cina bangun gedung di atas 50 lantai ya, kalau tidak salah itu untuk fasilitas COVID itu dibangunnya hanya dalam waktu 19 hari. Gitu ya. Kami bulan lalu itu mengadakan webinar bersama Wijaya Karya juga ada proyeknya untuk membangun rumah sakit untuk COVID itu dia bisa dengan metode BIM ini membangunnya dalam waktu 30 hari. Nah dia dengan bantuan ini juga modular-modular atau precast seperti ini. Nah ini makanya ini topik precast kali ini menurut saya pasti akan menarik sekali ya karena BIM ini sama precast ini kayak dua sisi mata uang juga ya karena kalau semuanya precast bisa diprecastkan gitu memang nggak semuanya sih kalau misalkan bisa gitu itu mempercepat sekali gitu proses pelaksanaan proyeknya. Kemudian tuntutan visualisasi, nah ini yang paling penting ya supaya tidak terjadi mispersepsi gitu kan. Dengan BIM ini dimungkinkan untuk membuat pemodelan kemudian divideoin jadi siapapun yang terlibat di situ mau dia orang teknik non teknik mau itu orang proyeknya atau bukan, siapapun itu bisa melihat dengan mudah karena kan bisa dilihat ya bisa di kayak video ya kiri kanan depan belakang jadi kelihatan semua sehingga mudah untuk dicerna. Nah kemudian tuntutan berikutnya adalah penghematan low cost. Nah, ini pasti ya siapa sih yang nggak pengen proyek itu untungnya banyak gitu kan tapi tetap waktunya nggak molor tercapai gitu kan sesuai waktu kemudian juga mutunya tercapai gitu ya. Jadi saya nggak mau makanya BIM ini sebenarnya bisa memberikan solusi-solusi untuk permasalahan-permasalahan di dunia konstruksi yang saat ini terjadi. Yang berikutnya definisi BIM, nah ini intinya BIM itu ya menurut ini yang kami cari-cari gitu dari berbagai macam literatur. Yang pertama BIM adalah database karena dia kaitannya dengan data digital. Kedua BIM adalah visualisasi karena dia mempermudah visualisasi dari setiap tahapan proyek. Walaupun nanti ini semuanya dirancang di awal semua ya di fase perencanaan baik 3D sampai 7D-nya. Jadi mempermudah visualisasi. Ketiga BIM adalah integrasi. Spiritnya BIM ini kan juga kolaborasi ya. Jadi supaya mempermudah arus komunikasi kolaborasi di antara stakeholder di proyek itu maupun siapapun yang terkait dengan BIM ekosistem itu ya. Siapa yang terkait itu mempermudah untuk kolaborasi karena semuanya platformnya kan digital. Bisa datanya digital, komunikasinya digital, kolaborasi digital. Jadi ini akan mempermudah sekali gitu untuk masalah kolaborasi. Yang keempat, BIM adalah metode bukan software. Di sini maksudnya adalah BIM itu workflow, metode kerja. Metode kerja apa? Metode kerja yang digital. Ya sebenarnya BIM ini tahapan-tahapan proyek sekarang yang konvensional itu dijadikan digital gitu aja supaya setiap tahapan itu ada digital footprint dan digitalnya file-filenya bisa terlacak itu secara digital intinya itu aja sih sebenarnya walaupun at the end memang dia pasti akan membutuhkan software-software untuk implementasinya gitu ya jadi bukan software tapi at the end masih butuh software untuk implementasinya untuk nah ini kalau misalkan yang cukup familiar di tentang BIM masyarakat ada ini ya ada dari 3D sampai 7D. Nah 3D-nya ini apa? 3D-nya tentunya modeling panjang kalau lebar kali tinggi ya bentuknya. Kemudian 4D-nya adalah apa? 4D-nya ini adalah 3D ditambah variabel waktu. Waktunya ada scheduling. Nanti kan dia kaitannya dengan metode konstruksinya ya membangun kan metodenya yang mana dulu nanti mungkin kalau kata dan precast mana yang mau di-install dulu dan seterusnya itu kan akan berpengaruh terhadap lintasan kritis dan juga pemudahan. Apa datanya dengan biaya jadi 5D ini 3D plus 4D plus variabel biaya 6D apa 6D berkaitan dengan hemat energi ini dituntut sekarang kan gimana caranya bangunan-bangunan itu juga bisa emisi karbonnya itu rendah gitu kan bahkan dipersyaratkan kalau di peraturan bangunan gedung negara itu ada perhitungannya ada persyaratannya supaya tidak menambah beban global warming ya climate change di sini diatur gimana supaya caranya hemat listriknya pakai nggak banyak lampu ya ditata gedungnya supaya banyak menggunakan cahaya matahari misalkan juga gimana AC-nya supaya nggak terlalu banyak ya itu udara disetting supaya sirkulasi udara atau kenyamanan thermalnya itu tercapai wifi gitu kan. Kayak gitu-gitu lah. Jadi sistem itu berkaitan dengan itu, dengan yang green-greenan ya. Kemudian yang terakhir ada second ini, apa second ini berkaitan dengan operation maintenance dan juga demolition. Nah, ini juga dirancang di awal bagaimana nanti operation maintenance-nya, facility management-nya, kemudian juga ketika umurnya bangunan sudah habis, gimana nanti demolition-nya gitu ya. Jadi implementasi BIM ini harus sebenarnya kalau idealnya kayak gini ya, semuanya diperhitungkan, semuanya dirancang. Tapi yang sejauh sepanjang yang saya tahu, kayaknya kalau di Indonesia belum ada yang benar-benar menerapkan ini secara komprehensif ya keseluruhan ya. Ada yang mungkin dia kontraktornya aja yang nge-BIM, tapi konsultan ownernya enggak. Gitu. Ada yang mungkin kontraktor dia menerapkan BIM tapi masih sampai sebatas 3D, 4D atau mungkin masih 5D, 6D, 7D-nya belum gitu ya. Jadi ini kalau yang 6D mungkin ada proyek yang menggunakan sampai 6D tapi itu karena dipersyaratkan atau diminta sama ownernya gitu ya. Jadi masih belum sepanjang yang saya tahu belum ada yang benar-benar 100% sempurna gitu. Tapi tetap layak untuk semuanya dicoba gitu ya. Walau bagaimanapun kan karena ini metodenya sangat baik sekali, jadi apa salahnya untuk dicoba gitu ya, untuk diterapkan karena ini banyak manfaatnya. Kemudian di peran PUPR dalam pembinaan BIM ini sendiri, karena memang sesuai dengan apa yang Bapak Menteri PUPR arahkan kepada kami, gitu ya, sampaikan kepada kami bahwa terobosan untuk mempercepat pembangunan infrastruktur, salah satunya penerapan hasil riset dan teknologi. Roadmap BIM seperti apa yang sudah disusun Kementerian PUPR seperti ini. 2017 adalah fase adopsi, 2019 digitalisasi, 2021 kolaborasi, 2023 integrasi, dan terakhir targetnya, cita-citanya 2024 itu industri konstruksi sudah 4.0. Gitu ya, 4.0. Walaupun ada yang sudah tercapai, ada yang masih meleset, tapi kita sampai saat ini sudah banyak sekali, sangat masif sekali Kementerian PUPR khususnya untuk melakukan ini di mana-mana kita bekerja sama, berkolaborasi dengan udah menggurita lah kolaborasinya gitu ya. Nah, salah satu yang paling utama yang perlu di-highlight dan perlu diketahui oleh Bapak Ibu serta webinar kali ini adalah ini. Kami dari Kementerian PUPR sudah mengeluarkan yang namanya Peraturan Menteri PUPR nomor 22 tahun 2018 tentang penggunaan BIM wajib diterapkan pada bangunan gedung negara. Sekali lagi diterapkan pada bangunan gedung pemerintah, negara, atau yang dibangun dengan APBN, APBD, yang bentuknya tidak sederhana atau kompleks, dengan kriterianya di atas 2.000 meter persegi dan di atas 2 lantai. Nah, ini diwajibkan untuk penyedia perencananya, untuk konsultan perencana diwajibkan di lampiran 4 di peraturan ini. Nah, keluaran-keluaran yang diminta dari peraturan ini apa saja? Ada 6 keluaran atau deliverables-nya, yaitu gambarnya arsitektur, struktur, MIP, landscape, RAB, BOQ, dan RAB. Jadi ada 6 itu yang diminta dari peraturan ini. Itu silakan dibaca aja di download peraturannya. Sudah diwajibkan ya Bapak Ibu ya. Nanti untuk proyek jalan jembatan bentuknya gimana Pak? Itu nanti juga akan menyusul. Yang paling dekat ini jalan jembatan akan dikeluarkan regulasinya tentang kewajiban menggunakan metode BIM di proyek jalan dan jembatan. Nah, Bapak Ibu, berikutnya adalah dalam rangka untuk bagaimana supaya BIM ini bisa cepat gitu ya, supaya cepat masif diimplementasikan, kami berkolaborasi dengan banyak sekali mitra, baik itu masyarakat, bisnis, industri, akademisi, maupun sesama pemerintah sendiri, pemerintah pusat dan pemerintah daerah. Sudah banyak sekali yang kita lakukan, tapi memang yang belakangan ini paling masif bentuknya adalah seperti ini, capacity building, pembinaan melalui pelatihan, webinar, ataupun seminar offline gitu, BIMTech, TOT, dan seterusnya. Itu yang memang paling banyak yang kami, khususnya Kementerian PUPR, lakukan untuk memasifkan BIM ini gitu ya. Kemudian yang kedua tadi regulasi sudah beberapa yang, terutama yang peraturan barusan yang 22 nomor 2018 itu juga sudah kita keluarkan. Nah, salah satu cara juga untuk kaitannya dengan pembinaan BIM supaya lebih banyak lagi yang bisa mengakses, kita bangun ada namanya Lab BIM PUPR. Itu nanti kita sudah beli 52 PC dan kita sudah bekerja sama dengan 7 provider software BIM untuk nanti di situ belajar software BIM. Dan gantian selama 4 hari, nanti ada Allplan, ada Tekla, Bentley, Ubicos, Archicad, Revit, Vico, gitu ya. Jadi ada beberapa yang kita kerjasama. Nanti informasinya silakan diupdate saja nanti melalui media sosial kami di @sibima konstruksi, Instagram itu ya, kemudian Facebooknya Sibima Konstruksi. Nanti kita informasikan melalui media sosial tersebut untuk bagaimana Bapak Ibu bisa mengakses kegiatan itu. Nah, saat ini sedang berjalan juga yang menarik yang mungkin bisa saya sampaikan juga, kami bekerja sama dengan CDDB UK atau Center for Digital Britain UK Inggris, bekerja sama untuk membangun yang namanya Komite BIM Nasional gitu ya. Ini memang dengan perantaranya Bappenas melalui nama programnya Global Infrastructure Program atau GIP. Itu Inggris membantu kami untuk masalah BIM ini, bagaimana nanti kita membangun institusinya, bagaimana regulasinya, standar protokol dan sebagainya, gitu ya. Karena Inggris ini negara yang paling ready ya, sudah paling masif penerapan BIM-nya, sudah ada standar-standarnya dan peraturan-peraturannya. Nah, Bapak Ibu semua, sebagai informasi juga kami untuk mendorong supaya mahasiswa-mahasiswa ini bisa lebih aware sama BIM, seenggaknya tahu lah, pernah dengar yang namanya BIM. Kami mengajukan surat ini, menyiapkan surat tahun lalu ke Dirjen Belmawa itu mengendorse supaya BIM menjadi mata kuliah pilihan minimal 2 SKS di perguruan tinggi. Gitu ya. Nah, Bapak Ibu mungkin kalau misalkan di sini ada yang pesertanya dari perguruan tinggi, kalau saya juga lulusan teknik sipil, menurut saya juga selain bisa dijadikan mata kuliah pilihan, bisa juga Bapak Ibu menggunakan strategi seperti ini. BIM itu ditempel di mata kuliah seperti gambar teknik. BIM itu ditempel di mata kuliah struktur baja, struktur beton. BIM itu ditempel juga di mata kuliah manajemen konstruksi atau manajemen proyek atau manajemen teknologi alat berat atau apapun itu ya. Itu tempel-tempel sesuai. Nanti kan tinggal dicari aja software-software mana yang mendukung itu gitu ya. Sudah banyak gitu. Jadi selain diajarin secara prinsip, dasar, teori, materi ya supaya kuat gitu, tapi juga BIM ini barangkali juga bisa disampaikan juga di mata kuliah tersebut untuk pelengkap ya, untuk supaya mahasiswa nanti siswa-siswa itu nanti ketika lulus mereka sudah lebih siap dengan dunia industri. Nah, Bapak Ibu, kaitan dengan industri, ya, penerapan BIM ini sudah sangat banyak sekali diterapkan di proyek-proyek infrastruktur. Ini beberapa yang diantaranya, dan masih banyak lagi yang belum tertulis di sini. Mau proyek bendungan, bangunan gedung, jalan, jembatan, bandara, dan seterusnya itu sudah banyak sekali menggunakan BIM. Kemudian kami juga melakukan banyak sekali kegiatan-kegiatan pembinaan ya. Ini ke seluruh Indonesia kerjasama dengan perguruan tinggi. Kebanyakan kami bekerja sama dengan perguruan tinggi untuk melakukan pembinaan pelatihan-pelatihan terkait BIM. Nah, ini tadi sudah saya sampaikan dari laboratorium BIM, targetnya 1.000 orang per tahun gratis, tapi ini letaknya di Jakarta. Nah, untuk orang yang di luar Jakarta bagaimana Pak? Silakan kalau mau datang ke Jakarta, tapi ongkosnya tanggung sendiri ya, penginapan tanggung sendiri. Kami hanya pelatihannya gratis dan konsumsi juga dikasih lah selama pelatihan. Nah, tapi juga supaya ini bisa menjangkau lebih banyak lagi saudara-saudara tanah air dimanapun berada, kita membangun kerjasama satelit dengan perguruan tinggi. Perguruan tinggi mana ada lab BIM-nya, ada lab komputernya, diinstal software BIM, kemudian orang-orang pada pelatihan di situ bareng-bareng sama kita, nanti kerjasama sama kami gitu. Jadi kita nyebutnya satelit ya, mitra satelit BIM. Kemudian selain perguruan tinggi, kita juga bekerja sama dengan provider, dengan badan usaha kontraktor misalkan kayak Adikarya itu punya Adi Learning Center. Kita juga ke depan akan kerjasama dengan mereka. Nanti peserta bisa belajar di tempat di Adi Learning Center, kemudian nanti instrukturnya pengajar dari Adikarya, yang nanti kepanitiaan, sertifikat dari Balai Penerapan Teknologi, juga guidance secara umum materi-materi apa yang diajarkan juga itu dari kami juga. Gitu ya. Jadi kita sudah banyak sekali bekerja sama dengan macam-macam ini ya, stakeholder. Kemudian kami juga bekerja sama dengan provider juga ada yang seperti itu, dia ada labnya seperti Kubikos itu, Kubikos Glodon dia punya lab sendiri. Nanti kita juga ada nanti nitipin orang-orang untuk belajar misalkan masalah Kubikos Glodon itu di kantornya mereka, di labnya mereka. Nah, Bapak Ibu semua, yang menarik hal ini adalah kita nggak hanya membina mahasiswa perguruan tinggi ataupun profesional juga ya, tapi kami juga ini sudah bekerja sama dengan Direktorat SMK, Dirjen Vokasi Kementerian Dikbud. Ini programnya Pak Mas Menteri itu kan intinya ada link and match ya, link match antara dunia pendidikan dengan dunia industri. Nanti SMK juga akan menjadikan BIM ini sebagai bagian dari kurikulum gitu ya. Ya seperti mungkin Bapak Ibu barangkali ketahui di negara-negara lain sudah banyak juga untuk level SMK itu yang apa namanya masih siswa-siswa atau lulusannya juga menguasai software-software tentang BIM ini. Ya tentunya memang kalau dari kami juga sedang menyusun yang namanya SKKNI, Standar Kompetensi Kerja Nasional Indonesia, itu nanti ada artinya akan dibagi-bagi, ada levelnya sesuai KKNI. KKNI itu Kompetensi Kerja Nasional Indonesia dari 1 sampai 9. Nah itu level 1 tuh nanti harus menguasai apa, 2 apa, yang paling tinggi 9 apa. Itu ada kriterianya nanti dan ada peraturannya. Itu sedang disusun juga. Nah, Bapak Ibu, ini yang terakhir agenda kami si Bima sigap berlatih BIM di rumah selama pandemi COVID selama April Mei, dan ini kita lanjut lagi bulan Juni ini, dan seminggu ini juga sama Olpan, dan ini yang hari keempat ya. Ini semua bisa diakses secara gratis, informasinya nanti Bapak Ibu silakan bisa dilihat, dicek di media sosialnya si Bima Konstruksi, di Instagram @Bima Konstruksi, ini ada tulisannya di sini ya, Facebook Bima Konstruksi. Kami ngomongnya di dua aja sih, di Instagram dan di Facebook. Kalau untuk video-video webinar yang sudah kami record, sudah beberapa di-upload, itu silakan dicek di YouTube channelnya si Bima Konstruksi. Nanti di-search aja di YouTube ya, si Bima Konstruksi. Nanti di situ silakan subscribe, like, dan share gitu. Supaya lebih banyak lagi yang bisa mendapatkan manfaat dari kegiatan pembinaan BIM yang dilakukan oleh Balai Penerapan Teknologi Konstruksi, Direktur Jenderal Bina Konstruksi, Kementerian PUPR. Itu saja mungkin Pak Sis dan Bapak Ibu semua peserta. Selamat belajar tentang PLANBAR ini, semoga bermanfaat. Nah, ini informasi terakhir, nanti di menjelang akhir webinar ini kami akan share link feedback itu untuk daftar hadir ya, untuk absen sekaligus untuk mendapatkan e-sertifikat. Jadi kita nggak nyebar link sejak awal, nanti di akhir aja, jadi absennya di akhir, terus juga sekalian itu database nanti kami gunakan untuk mencetak sertifikat. Nah, untuk kaitannya dengan sertifikat, supaya rapi nanti nama sertifikatnya, kami mohon nanti Bapak Ibu bisa menuliskan namanya secara rapi, misalkan huruf depannya itu huruf besar, kapital, yang lainnya kecil, atau kapital semua, terserah, silakan saja. Kemudian kalau misalnya mau memasukkan, mencantumkan juga gelar akademik, silakan. Karena nanti kami akan mencetak e-sertifikat itu sesuai nama lengkap yang Bapak Ibu tulis melalui link Google Form nanti yang kami share di akhir. Dan untuk tautan informasi tentang e-sertifikat akan kami berikan melalui medsos Instagram @Bima Konstruksi dan Facebook Bima Konstruksi paling lambat sebulan setelah kegiatan ini. Tapi mudah-mudahan kami akan berupaya supaya tidak sampai sebulan lah. Nanti dicek aja dicek aja di Instagram dan Facebook, nanti kita akan informasikan tautan dari Google Drive untuk Bapak Ibu nanti download sendiri sertifikatnya. Baik, itu saja mungkin yang bisa saya sampaikan. Sekali lagi selamat belajar, semoga bermanfaat, dan mohon maaf apabila ada yang kurang berkenan. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. Silakan kami kembalikan kepada Olpan.
Terima kasih
kepada tim PLANBAR, sorry.
Terima kasih Pak Reza. Jadi setelah ini Mr. Max akan membawakan presentasinya. Max, I think now is your turn.
Right. Okay, thank you. All right, hi. A very good afternoon, everyone, and we are very excited to welcome you. Just 1 minute. Let me switch on my camera. All right. Very good afternoon, everyone. Yeah, so this is Max from Precast Software Engineering, and I'm very glad to have the chance to present to all of you today. Yeah, so I would like to thank Mr. Reza from BTPK, PUPR, and also Mr. Stephanus from Piranti for organizing this and making today possible. Right, so before we begin, right, so some things to note. So everyone will be muted, and you may raise your hand if necessary, right? And there's a question box on the right side you can ask. And this webinar will be recorded, and the link will be sent to all participants. Right, so today, including myself, there will be 3 presenters. Firstly, we have Jason from Philippines. it is our customers excellence and technical support. And we have Mr. Siron Hoyut from Thailand and myself, Max, from Singapore. Yep, so it's a very diverse geographical distribution today. We have people from over 4 countries in this webinar. So we thank you for your understanding regarding the quality, especially the sound or picture due to connectivity issues. And below we can see my team in Austria, Salzburg. So they are all supporting us from Austria as well. All right, my apologies. So, yep. Apologies for the technical glitch. Right, so you can see this will be the presenter today, right? And if you have any questions or regarding our product or any questions at all, you can contact Mr. Siswanto, Director of PT Piranti Sarana Technologi, and also myself. Yeah, you can take down the contacts below, or you can just leave your contacts in the questions box. Right, so short introduction for my company. We are part of the Dynamic Chat group, and I think some of you have also attended the All Plan webinar for the past 3 days. So as you can see, we are part of 16 strong brands under the Dynamic Chat group, which is listed in the German stock market. Yeah. So for the whole company, right, we have over 2,500 employees around the world, and under us we have multiple brands, including Allplan, Solibri, Graphisoft, etc., etc. And we spread over 3 major part of this BIM, the whole BIM environment, from design, build to manage. And we actually work very closely with each other to develop good products for our customers. Right, so for precast software engineering, we actually carry 2 major products. One is PLANBAR, which is a comprehensive solution for high quality industrialized precast parts design. And today my team will be mainly talking about PLANBAR. And we also have a TIM, which stands for Technical Information and Integration Manager, which is a platform for you to manage your whole precast process as a single source of truth, which I think all of us, or most of us has heard of this term in the whole BIM situation, right? And we will be briefly talking about this as well. So for BIM, actually is a very hot topic that I think Mr. Reza also explained very clearly, and I think my colleague in our plan also has explained quite substantially over the past few days. Right, so for BIM, it's actually part of a bigger scheme of things that in Singapore we have actually adopted. So the first step is actually BIM, whereby you have all this 3D information and the design analysis, etc. Then for the next step, we have the VDC, which is virtual design and construction, encompassing BIM to field. So you use the information from BIM and applies it to the actual construction itself. And lastly, what we are doing now is actually called the IDD, Integrated Design, and so this is actually the whole ecosystem from BIM to field and also to maintenance of the building as well. So we have facilities management, or even all this maintenance of the building, etc., and also sustainability issues. And for today, we would like to talk about more on what is actually BIM in precast system, right? So firstly, we have the advanced precast system, advanced precast concrete system, whereby you have different principles which has to be adopted for more efficient precast design. So we can see that there's mechanical joints instead of using grouting, and we have larger standardized precast panel slabs for easier manufacturing and construction. And we also have the integrated precast components, whereby you can make use of the manufacturing capabilities to construct and build more complex structure in a factory environment, so you can control the quality better as well. And one very hot topic currently is actually PBU and PBVC, which is a prefabricated bathroom units or prefabricated volumetric construction. Right, so this is actually slightly different from an individual precast panel, and the advantage is actually quite significant in terms of the time saving, the safety, the quality, and also the manpower reduction. So one case is that in Singapore we have a project which should have taken 12 months to complete, but with PBU and PBVC, the time was shortened to 4 months. And with most of the manufacturing actually happen in the factory environment, there is lesser chance of accidents on construction sites. And also in the factory environment, you can control the quality better as well. Then for manpower, especially in European or in Singapore, where manpower is slightly more expensive, so manpower cost saving is actually quite significant as well. But for this PBVC and PBU construction, you will need to have a very close collaboration using BIM solutions, right? So from planning to negotiations between stakeholders, to discussion on how the sequence of constructions, to transporting, to hoisting, all this has to be closely collaborated to make sure that this prefabricated unit can actually be used on site, and it will be very costly to dismantle or rectify if anything goes wrong. Right, so this is a very short video on how actually we can use our solution for this PBU and PBVC construction. So is all these individual elements are actually pre-designed, and you can just allocate it in the plan itself. And as you can see from here as well, we have multiple different views from 3D to 2D, and I will explain it briefly again later on how this actually helps people to use our software easier and learn faster as well. So PPVC is actually quite popular in Singapore, and the government is also pushing very hard for this initiative. And for design wise, I think it will be easier because ideally all the components should be standardized more or less. Right, so you can see all the details, and my colleague will demonstrate to you on the interface later. Right. Another thing that we stand for is actually open BIM. So I think this is also one of the hot topic in the industry, because I think on the market, no solution it is 100% no solution can do every single task. But for precast software engineering, I think we encompasses more or less most of the stages in the project precast project workflow, right? So with a open BIM platform, we actually uses the IFC model to achieve interoperability with other softwares, including the more popular ones like Revit, etc. Right, and we even take it to another step, and we are actually able to produce precast parts from IFC models. So we send the data directly to these machineries, and they will read the IFC model, and it will be produced automatically. And we also have the MEP system, which we will also show you later, right? And it's integration of the mechanical, electrical, and plumbing model to our precast model, and it will actually save you a lot of time. Right, so we are part of this IFC for precast group, and on this on the third person on the bottom left is actually my CEO back in Austria, Salzburg, Austria. Yes. So we are in a group to discuss what is actually the standard for this IFC for precast. And as you can see, there are multiple benefits from it. You can achieve more optimal interaction between CAD and MES system, reduce the coordination time, and there will be a clear traceability and accountability for all the models that you build in real time. Right. So for BIM in practice, I think one of the key things that we want to achieve is that you can encompasses all the stakeholders. You have the MEP designers to come and to incorporate their models in the precast model. You can send a precast model to structure analysis for the structure engineers. Then they will check on the structure integrity of the whole model, etc. And this is actually achieved by our open BIM concept through IFC file. Yeah. So this is some of the maybe a sneak preview of how we import IFC data into our precast model. So you can see we just drag the MEP model inside to this file, and we can select what kind of openings that we want through this very simple list. Right, then you load these fixtures or installations on this precast model, and all this will be done automatically in a very short period of time. So for this whole video is around, I think, 1 minute, and we can actually import the MEP model, create openings and fixtures, then create a shop drawing directly from this. And what more is that we can actually use the data to send to machineries and for production. So you can see that all these shop drawings are actually completed just like that. And my colleague will actually show you how easy it is to create and change shop drawings afterwards. And why we are so integrated planning is one of our philosophy when we created our software. So we want to make sure that all these project workflows in a very smooth way so that we minimize the information loss from calculation to design to work preparation to production to data and report, and lastly to information management even on a mobile platform. So this is the curve that we want to achieve. You can see from here, right? Every steps you have different stakeholders taking charge of these shop drawings or architecture drawings, for example. And when it's passed on to the next stakeholders, some information is lost on the way because nobody is perfect. Maybe you left out some information, or you send the information slower. This kind of human errors. But with machine and computer or technology, we can eliminate all this and achieve a smoother curve, as you can see here. And other than that, we also stands for open BIM, right? So this is actually the benefits that we have with MEP Assistant and IFC Assistant to reduce this data loss when you are doing your precast design. And so the whole process is actually quite simple if you know AutoCAD, for example. So from 2D, you can create a 3D model, right? For the whole, then you can create a shop drawings in a very quick and efficient and error-free way. So I think a lot of people sometimes when they create shop drawings or when they adopt BIM, they will do the shop drawing first. Then afterwards, they will create a 3D model, which is actually counterintuitive if you think about it. So these are also some of the capabilities that we have, and we have actually a database for some of these more common, or you can actually download these connections from the supplier's website. and you can incorporate it in our PLANBAR solution. And because BIM is it will consume a lot of computing power. If you think that, you know, one precast element maybe 5 megabytes or 6 megabytes, for example, and when you have 1,000 or 2,000 precast parts in the whole project, and you have over like 6 or 10 projects, and all this data becomes unmanageable, right? So we also continuously improve our solution to make it faster, so that it will not consume so much computing power. And we also come out with innovative ways to identify similar precast elements in the project, and we group them together to manage them together. Right? So you can change one precast element, and if they are the same, it can be applied to the rest of similar precast element as well. So it will be synchronized and updated automatically, and it will help you to manage this project better as well. Right, so element plan is actually one of our key feature that we want to encourage, because ultimately what matters is actually the shop drawing, which has to be used for production. Right, so with PLANBAR you can work in 2D, which is a more familiar ways for a larger part of you. So for students, etc., you don't have to relearn 3D modeling. You don't have to learn parametric modeling, for example, and you can use PLANBAR. But of course, we do have 3D modeling features, or even parametric modeling features as well. So depending on your skill set and your confidence level, you can choose which one you want to use. So later, my colleague will also demonstrate to you how this 2D and 3D interacts with each other. By changing the shop drawings, you can change our 3D model, or from 3D model you can change the details in your shop drawing almost immediately. So you don't have to you know, do multiple steps to make the changes. And next pain point that we see a lot from, let's say, BIM modelers is rebar detailing, right? So there are a lot of standards, a British standard, the European standards, etc. And you have to make sure this rebar is actually compliant with these standards, and you have all these different openings, etc. Right? And it will be very tedious to put in one by one. But with our solution, there is some automatic reinforcement placement, and all this information can also be used for example, mesh rotting system. And I think that for now, I can say that we are the only one who can guarantee that our data is actually compatible with this mesh rotting system. All right, so maybe let me just pass the screen to my colleague, right? And he will show you the actual demonstration on how this can be done. So, Siren, please, I'll pass the presentation to you.
Okay, thank you, Max. Wait a few minutes. Okay. Okay, thank you, Max. Hello, everyone. My name is Silan from Thailand. Today, our topic is the ultimate precast workflow with PLANBAR and TIM Part 1. I work as a precast solution manager concentrating in the BIM precast workflow. Today, I would like to talk with you about how to use tools from PLANBAR to create facade wall elements, precast wall, and precast slab. So, I will show you how PLANBAR working. But before I start to do the presentation, I would like to show you, okay, this is one of the model from customer in Thailand who are using PLANBAR to build up 3D modeling for the facade wall elements. And I will show you now how PLANBAR working. Okay. So if you want to make a facade wall elements, you need to create architecture wall first in PLANBAR, right? So with this, I want to create wall in this area. So let's start with architecture wall. Okay, I just make one wall here with 10 centimeter thickness. Okay, we have wall here. And then from architecture wall, we change architecture wall to the precast wall. We got it already, precast wall. So in the design window, you can change or input any value that you want to show in your layout. For example, right now at the moment, the precast type is a type LG1, but I want to change to type LGA. You just type it in the box of the additional attribute, and then you will get the result like this. So after you have done the design of the precast wall elements, you can use the connections from the design to make a wall segmentation. From the wall segmentation, you just click on the precast wall. And then you can choose the connection that you want to have. So, okay, and here, and here, yes. And then one more, I want to make a wall segmentation at here. Just click on that. And now you have a new wall with the new name, and of course you can see some information about the width of each precast wall. It's a 1.85 ton right now at the moment. So from here you can create reinforcement by using basic reinforcement and select precast wall, and in a few seconds you will get the reinforcement. Okay. This one. Change some setting here. Okay. Okay. And then I want to create some fixture from existing wall element. I can transfer element from existing element by select. And now you get all the objects that you want to have. Okay. And if you want to have the shop drawing, you just click on precast wall elements, and you will get the shop drawing. But with the details of the shop drawing, my colleague Jason will explain you again how to create this shop drawing. Okay. And if you want to let's say create some additional elements for your facade wall element, when when you look at these facade wall elements, right now at the moment you don't have sunshade on the top of the window, right? In PLANBAR, it's very easy to do it. You just go to fixture and then select picture and draw it. In a few minutes, you will get sunshade on the top of the window. And of course, if you want to, let's say, create a connection at the top of the wall or even bottom of facade wall, we have possibility to do it by in a few clicks. You just select fixture that you have and you just draw it, and now you get top key of your facade. And even at the bottom of your facade element. Again, a minute. Okay. This is horizontal connection for your facade wall element at bottom, and this is horizontal connection for your top facade elements. But and in case of you want to make some opening, we also have possibility to do it by using cutout. You just use negative and then define size of your opening and depth of it. Right now, the moment you have opening, and at any time you can delete it if you don't want to have it. Okay, but for the facade elements, if you have the complexity of elements, you can use our new technology that we say is Python path. From the Python path, you just select Python path that you have in your catalog. That's it. And then you will get all the things that you want to have now. But with the Python path, it is a parametrics. So parametric modeling from Python path is helpful for you to, let's say, resize of your geometry, even height of your facade wall elements. And of course, you can switch on off reinforcement. And now you can see when we resize your facade, resize facade wall elements, reinforcement automatically adjusts according to your configuration. Okay, let's switch off reinforcement. And for the shading, if you don't want to have shading, you just uncheck options in your Python path. And this is the result of your facade wall element. Okay. And of course, if you want to modify horizontal connection, we also have possibility to change type of the connection on the top and on the bottom. It depends on your design. Okay. And for the Python path, actually, it's not just the facade elements. You can use Python path to fulfill all your design. Let's say, for example, if you want to have automatic reinforcement, we also have an example of Python path in our system for our slab, for the beam, for the column, or for the T-beam, whatever it is. You can see in the example of the Python path in our catalog. Okay, this is the facade wall elements. And The next one is I would like to show you how to create precast wall elements. Okay, let's start with the PDF file. Imagine if you want to build up 3D modeling from 2D, and sometimes you don't have 3D, you don't have DWG file from the designer or from our owner. Mostly you get a PDF file, right? So with PLANBAR, we are really open for the technology. We can drag and drop PDF files and then select number of page you want to import. Let's say number 3. From the number 3, now you get the data from PDF in PLANBAR. So we just assign PDF as the reference because we want to build up the wall. How to create wall? Just want to create wall. Here and here and here and here. Sorry, is something wrong? Is that middle? Okay, I just move it if something wrong, but okay, it's not wrong right now at the moment. Let's say I have done one outer wall at the moment, and inner wall, of course, you can draw it again, but I can mirror it from existing at the moment in here and here. Okay, and if there is some clashes between two walls, it appear in the yellow. You just delete it. Okay, and now we have done the, let's say, the wall, and if you want to create some, let's say, some window opening in PLANBAR, it's very easy. You just go to window opening and of this define height of opening in the properties window, and then I would like to have our opening for the window at here. I just click on it and okay, I need 1000 from the left, and width of opening 1080, 1800. Yes, now get opening here. Okay, let's say I have done the precast wall, and now I want to make a precast wall elements. I just go to design again, and from the design I have to select precast architecture wall. In a few minutes, in a few seconds, sorry, you will get precast wall elements. And you can, let's say, modify mark number. If you want to have the, you want to start first mark number from 101, you just change in label mark number to 101. And then the first wall will start from 101. And of course, in additional text, you can customize any additional text from W to WA with dash, with any symbol that you want to show. And it's not fixed actually for the information showing now on the screen. If you want to customize any information showing in layout, you can do it by your own. Okay, after I have done to the design of the precast wall elements, I have to go again to connection. From the connection, I just want to make a L connection. Select, and you get L connection at the moment. And if you want to have it on the other side, you just go to section and change to the other side. even here. And the connection at here is not fixed actually, it's a parametrics. Let's say, for example, if I want to have a connection at here, and this is actually the three direction of connection, and you can see now we have the 3 while loops. If I want to have 4 while loops, it's very easy actually, because it is a parametrics. You just select and change offset to 20, and now you get 4 or 5 connection, depends on your parameters. Okay, and in case of you want to make a wall segmentation at here, you just click here, and of course you can change to, let's say, this type of the connection. And don't worry about your standard. For any type of the connection that you have in your design, from your design, you can adapt it by using PLANBAR. Because our solution is really open for you to customize anything that you want to do. Okay. And then after I have done, let's say, connection for the wall, I go to basic reinforcement. From the basic reinforcement, I want to create reinforcement with any items such as lifting bolts, collocated pipe, wire mesh, or attached reinforcement. I just load my preset. From my preset, select Precast Workflow. In a few seconds, PLANBAR will generate reinforcement with any items that you need to have. You can see now, in a few seconds, you have lifting bolts, you have reinforcement, you have collocated pipe, and of course, you can set a loop. If you have a fixture or items here, the system will automatically cut reinforcement. It depends on you. We are really open for that. If you don't want to cut out reinforcement because of you have a fixture here or you have items here, we are really open for you to customize it. And okay, what happens if I come back to the design again and go to connection, because I want to create connection at here. I create connection again, and now you can see the system will automatically create a new reinforcement with the two different parts of the wall that we are create a connection. Okay. And okay, if I come back to model view again, from the model view, if I want to let's say have some opening, now you can see what happened. The system will automatically generate extra reinforcement around opening. And of course, reinforcement also cut out because you have opening here. And in case of you have to resize openings, you can see what happened after this. The system will regenerate position of lifting bolt according to your CG, even the extra reinforcement already move. Position of connector already move because of your condition. So for the precast wall, we have a more automatic system to help you to increasing your productivity. Let's say, for example, if you want to have if you want to build up the 3D modeling, we have a better tool for you to use. Okay, that's all for the precast wall. But not the last, because for the precast wall, it's not just a concrete wall. If you want to create double wall system, sandwich wall, thermal wall, and wall consisting for n layers, we also have solution as well. It's not just only concrete wall available from PLANBAR at the moment. We have various types of wall, precast wall that you can using from PLANBAR. Okay, and the next one is I would like to show you how to create precast slab. To create precast slab, okay, I switch off PDF. Open just our precast wall. When you look in the design of precast slab, we also have various types of slab. Half floor, hollow core elements, pre-state hollow core, concrete slab, and so on and so on. So let's start with the concrete slab. From this concrete slab, actually you have to define thickness of your slab, define concrete grade, covering, and everything that you want to do for the preset, you want to have for the preset, even the additional text for mark number. And of course, you have to define connection or connecting between elements. And in case of you have bend bar, like the joints between elements, you can also predefine at this window. Okay, let's start with the basic slab. For the basic slab, I just click on this area. And now you can see we have slab already. In this, when I say okay, you will get all the things that you want to have. For example, connect joints between elements, lifting angle for slab, okay, and reinforcement. And now you can see on this side there is no joint because of this is end face. This for the wall. If you want to modify it, you just modify this side and select on this side. And from here, you can define joint. And when I say okay, now we have joint here. Okay. And in case of you have bar protrusion or extrude from precast slab elements, we also have possibility to do it. You just go to properties, connecting joint, and okay, I have to activate bending shape. Of course, I have to prepare it already. And now you can see what I have when I click OK. You have bar protrusion or bar extrude from your precast wall element as a reinforcement connection. If you want to have different shape for the connection, our solution also are available for you. You can choose which one is fine for you, but don't forget to assign any value for any bending shape. Otherwise, you will not get any result. And when you and when you asking about end connection on the left and on the right, and on longitudinal side, you can also have it. I just go to design again, and from the design I have to go to bar projection. From the bar projection, I just load the setting for the bar connection, and then I say OK. Now you can get bar connection at the end phase from the start at the end. Okay. And if you want to modify reinforcement, you just modify design and select reinforcement that you want to change. For example, I want to change from 24/10 to 20/10. And then I just say OK. And the system will update reinforcement for you with any, let's say, joint detail. And OK, when we look at slab segmentation, if you want to, let's say, resize of your slab segmentation, you can use this function to make the new slab segmentation. Just click on it and escape. The system will generate new slab segmentation. And of course, you can modify support as well. For example, if I want to make the support longer than a wall, firstly I have to make a support separation, and after I have make a support separation, I click on this support, and support width should change from 4 centimeter to 20 centimeter, and then I'm OK, and then I'm OK. And now you can see support is already extended from the beginning around 20 centimeters. And when you want to, let's say, have some opening on this slab, I have to okay, start with few. Okay. When I want to make some opening in the middle of the slab, I just make it, and then the system will automatically cut out reinforcement, even changing everything as you preset before in your catalog, in your configuration. And of course, extra bar opening are also available, but I'm not showing in my setting right now at the moment. But when you move something, when you, let's say, move, it's also update, resize. Okay, and you can copy opening from this slab to this slab as well. And if you want to resize your slab, you can do it easier by using stage entity. And in case of you want to change the, let's say, thickness of slab or whatever it is, you just go to the design, change parameter, and this is a parameter for slab thickness. You can change it at any time that you want. And on the other thing is, if you are not fine with this slab direction, you just go to span direction. In the span direction now, I want to go to 0 degree. And then I go to set fixed point, make element division here. And say okay. So you can see now our solution is very easy to make the modification, update all the things that you have to do for the slab. For example, opening, and of course I just delete opening and the rest will be updated. And if you want to copy it, it's really easy actually. You just copy or mirror, and now you will get a slab like this. Okay. And the next one is half floor. Let me delete this one, and then I have to hide. Yes. For the half floor, normally half floor we have girder or we have alpha touch, right? So if I want to have half floor on this area, I just use area detection and click on it. The system will generate automatically half floor slab with the segmentation. If you are not fine with this, you can again change the slab segmentation easily by clicking. And of course, you can change starting point. But okay, at the moment, width of half set is over limitation. I just delete it and create a new slab segmentation at here. Okay, it's not fine actually. Okay, or I change span direction to here. It should be fine. And then I say okay. And what happened? You can see now we have half slab with wire mesh at bottom, and on top of wire mesh we put girder, right? And for the girder, you have possibility to move it by manually if you want. This is after, and this is before. Okay. Or you can go to modify design, and then from here you can go to lattice girder, and okay, you want to lock spacing of the girder. Let's say for example standard is 40 centimeter or maybe 60 centimeter. At the moment I need 20 or 200 actually, because I'm working millimeters. And then I just say okay and okay. And now this is a result of the girder. It's the same actually with the concrete slab as well. About opening. If I want to make an opening here, the system will automatically generate or cut out reinforcement with girder. Even you move it, it is the same actually. Okay, this is because of the minimum length of your girder cannot produce from the machine. That's why our system will not creating any girder at here. But you can make a manual secondary girder by using secondary girder. But okay, at the moment, I'm not showing any more regarding the secondary girder. Okay. And the last one from my side at the moment is hollow core. When we talk about hollow core, actually normally you have machines to produce or to create a hollow core slab element, right? With the hollow core slab elements, when you look at type of hollow core, you can create any type of hollow core that you want to have. I will go deeply in a little bit detail of configuration of hollow core. If I go to hollow core, you can customize your profile of your hollow core. You just have to define parameter. Let's say, for example, panel thickness, number of your core, and even the, let's say, standard panel width, minimum fit panel width, and so on and so on. So after you have done the catalog for your hollow core, to make hollow core in the 3D, it's very easy actually. You just go to properties from hollow core and then select type of hollow core that you want to have. And from here, I just want to create VSD 8.16. And again, I have to use area detection. From area detection, I just click on it. And now you get hollow core. It's very easy to make a hollow core system. The cutting it will following the rules or conditions of your configuration, because we are not allow you to cut your hollow core as width of hollow core, right? But this is not on the restriction of the rules. So that's why the system showing the cutting at this area. Okay, it's the same actually with the slab elements. If you want to change span direction, just go to here and change to 0. Okay. Even the, let's say, type of hollow core, you can change at any time. Connecting joints of hollow core as well is also available. And one more thing I want to explain you for slab modules. In the slab module, you know, if we have various type of slab, but mostly people ask me about if you want to, let's say, move up or move down our position, our level of the slab, how to do it. You just go to height and then define here, okay, I want to move down my slab minus 500. I just put minus 500 here. And then if I don't want to use area detection, I just, okay, say no area detection. And then I go to concrete slab again. And from the concrete slab, I just, okay, define okay. And if you, let's say, don't want to have any joint, yes, you can do as well. You just click and say, okay, no, I don't want to have joint here. But at the face, okay, at face I need. And okay, now go with 2040. Of course, new segmentation. And this is the gap between elements. It's just 1 millimeter. I go with 10 millimeter. Whatever you want, you can do before you say okay. And then I just say okay. Now you get all the thing. Or even the lifting. In the lifting, actually, when I go to lifting board, we have 3 options right now at the moment available. We have based on weight starting at the center of the cavity, or based on panel length starting at outer edge. You can check by your own how it's working. Okay, so regarding to slab elements, and again, if I have more possibility to show you right now at the moment. Okay, if you want to, let's say, change steel gauge, you can do here, and even you can add more reinforcement by using attached reinforcement. You can go to longitudinal bars and crossbar. And of course, for the shop drawing, you just click on it, and then you will get the shop drawing for the slab. But I will not extend you anymore because my colleague Jason, he will take over this part. But for the shop drawing, we are very flexible for you to, let's say, make anything that you want to have. Okay. So, regarding to the question, so that you want to talk something to him? Because someone is asking for automatic placement for lifting hook. If you can confident to present, then you can show. You mean for, sorry, the question is, you mean for wall or you mean for step or for both? Okay, maybe I can show you for both. Makes sense to do. I come back to wall. Now you can see this is automatic lifting bow or lifting ankle. Okay, I have to come back to properties, to the basic reinforcement. Okay, and then in the lifting bowl, you have many possibilities to, let's say, to set the condition and rules to have the automatic lifting bowl. And of course, we have automatic lifting bowl, and this is a window that you can set any parameter or set any condition for your lifting bowl. This is for wall. And for slab as well, as I show you, when you go to this, and lifting bowl. On the lifting bowl, we have 3 options to get or create automatic lifting bowl. We have option 1, we have option 2, and we have option 3. So for the slab and wall, I would say we have automatic lifting bowl, and you can use this automatic system to create your lifting bowl for slab, for example. Okay, maybe this is that all from my part, and then I will pass my screen to Mr. Jason, my colleague, who will responsible for next topic. Thank you.
Hello. Thank you, Mo. So now, to continue the topic that my colleague was presented, so I will be discussing now regarding the different types of precast that you can do using the structural precast elements. So aside from those precast eye walls or walls and eye slabs, we have another module that called structural precast elements. So because there's a lot of elements that you can possibly do. So just the background for this, it was commonly used for columns, beams, staircase, and other shapes. Especially if you can see, there are some volumetric or irregular shapes. It can also be used as simple shapes as well. So if you can see from this one is actually a slab. So you can still use the structural precast elements. As what I mentioned, so you can have the wall, different types of wall. You can have the column. You also have the beams. So you can use beams. You can create very complicated beams. And as what Max told us earlier, that the PPVC PBU is actually made of structural precast elements. So to show you more on the project, real project, I will just open a project. So just to have a background of this project. So this is one block of about 10 blocks for one project. So this is a project of one of the precasters in Singapore, which is the Greyform Private Limited. This is actually EC or executive condo type of structure, which composed of 10 blocks and about 16 story per block, plus basement, edex, and roof. So the PC elements here, as what you can see here, is actually all are precast. Even the simple ones, as what I mentioned, simple walls. You have also for the lift core area, you have the ducts and the staircase, etc. So it means the structural precast elements is actually possible to do in any shape, to use to any shape. So I will try to show you that, like for example, on this featured roof. So it's something like an irregular shape. Okay. And if I can load the detail of this, then you can see that this kind of shape here is really possible to do using the eye or the structural precast elements like this one. So as you can see, it's not normal because of this, I can say still complicated one because of the irregular shape. The next one is another project from Greyform, wherein you can see other types or kind of precast elements. Well, initially I have shown you the beams and the columns. So these beams are not just ordinary beams. So if we can see, the shape of this is actually really huge precast elements. Even the columns, even these core walls. So if I can just go to certain level to show you how it looks like. So because this one is really difficult to produce, so normally they use precast elements, especially for irregular shapes. So I will just load maybe the level 3. And by the way, this project is actually a 29-story office office development with a 5-story podium consisting of a first story restaurant, second story is the main lobby, and the 3-story car park. So all of the elements here are actually precast also. So maybe I just open this. Just third story, and just to have the dimension. So you can see, just to show you that when you have a huge project with a big or a different type of precast elements, then you can still use PLANBAR to create them as a precast using the structural precast elements. So as you can see, there are beams that is actually almost a 9 meter and with almost 10 meters. So excluding this part. So if I'm going to show you closer, so this part is that one. So it's really a big beam. This beam actually depth is about 1.2 depth, 1.2 meters. Okay, so now to show you, I will go back to my project to show you how to use the structural precast elements. So again, these are the samples. So the PBBC or the PBBC PBU is this one. So how can you use the structural precast elements? So first is actually you can do the same procedure as what my colleague showed. If you have PDF, you can use the PDF to refer. But at the moment, since I will be doing just an individual element, so I will just going to show you how to create a precast element using structural precast module. So first is you're just going to use this 3D modeling, and you can just say, I will create a 3D object to make a column. So I will specify the dimension of 1.5 by 1 meter and the height of 2.5 meters. So initially, this will be your precast elements. Then, I mean the 3D model. So to convert this as a precast elements, you just have to go to this precast elements and select this icon, which is the structural precast elements. And I will just load my predefined. Okay. So you have this properties, a column, 3D, and then PC precast. So just have to fill it all the informations here that you need to, including the dimensions if you need it. So I will select the 3D element. And once you have this marking, it is actually a precast element already. So how are you going to cut, or how are you going to make this how to make this 3D model to be the same as per the standard? So let's say, for example, I'm going to put reinforcement. So since this one is a precast, I can already put reinforcements. And basically, I will use first maybe the links. And then, by the way, I can go to create views or edit element, same as my colleague has done. Or either you can also create a view by your own. So you can have it here so that you can control more. You have a control. So I'm just creating different views. So you have the top, side, and the front view. So again, I'll start with putting placing the reinforcement. So once you have created this 3D object to become precast element, you can have this reinforcement specifying what are the types that you're going to use or shapes. So you have different shapes here. And then let's say I will use first the links. So I will just load my preset and say I'm going to place bars here. So as you can see, it's adopting the shape. And I can say place bar shape. And as you can see, you can have the bars there. But on this case, you can still modify the spacing. So you can have, maybe I just stretched it a little bit. Okay. You have the spacing of maybe 150. You can change from this setting, or you can predefine the spacing that you want to have. So for example, I want to space from this area be 1000 to have a spacing of 100. Oops, 100. Then another placing bar from here to here to be maybe 200. Where is my setting? So you will have this different spacing for your links. So as you can see, it's already inside. Next, let's try to put the vertical bars. So how are you going to put? Is this actually the same? So you're just going to, okay, you have to create the bars and just choose the shape that you're going to use. So let's say, for example, the straight bar, that's for the vertical. And I will just load my preset. And if you're going to look at this, I'm going to check this one in adapting my boundary. So if I click here, and I can say my place bar. So it's the same procedure as what we did um, in the links. So I just specify from here to here, and that's what you can see from here. You have the bars there. So we just have to modify the spacing. So maybe just to maximize it. Okay. And as you can see, you can change the bars before you place them, the concrete covers. So again, I can do again one more time for the other side. So I just close this one. Okay, again, so bars. And just to show you, so I will just put this 175 and this one is 175. So as you can see, when you modify from this concrete covers, it's automatically adjusting from here. So this will be your guide. Okay. So, and I'm going to place the same way as was what we did. And let's see, from here to here again, and it placed on the other side. Okay. So another thing, you want to put more bars, we can complete this one. Maybe you can just do a mirror since they're already placed. So we can just say mirror from here to here, and maybe this here to here. So as you can see from the model, it's already updating. So the next thing is, actually you can place all different kinds of bars. So maybe we can try to put also the hooks. So maybe I just use a form here with a straight bar with hooks. Okay. And then you just predefine what will be the setting. So maybe I can just place my hooks instead of expand to adapt edges. I will just remove that and just select just this part and this part. So as you can see, I have already the hook shape. So you can still modify this if you want to have a longer hook length. You can say change from here, or even you can also the degree. If you say 90, you can just use as 90. So it depends on your design standards. And then you get to do place again the bars. And maybe I can just say automatic placing of the hooks. Okay. So it's really easy to place or create bars using PLANBAR. Then the next thing I can put is maybe another links inside. So I will just place another bar shape and create the shape of stirrup closed, and now it's a link for inside. So maybe I can just from here to here, and I will just say this will be the location of my hook. Okay, should be this one. You can modify again. So let's say the concrete cover from this side maybe 25. This one will be 32, 25. Okay, 32, and that should be it, just to fit in here. And then you can place bar shape automatically. So you can see from here, I can make it more visible. So I will just change the transparency, so maybe about 49 or 50. So you can see all the reinforcements can be placed here at this short time. So another thing that you can do for this precast elements to make it more a little bit complicated, maybe you can put also some fixtures or curb on top. So I will just put some fixture, like I think my colleague already shown you. They have some different levels on top and bottom. This is something like to prevent for something like a waterproofing. So once you have placed that, and as you can see from here, you will have this curve. Again, let's say we put it for the bottom. So we'll just do the same. We place this fixture. And let's see on the top bottom. So I just press escape and say okay. So as you can see, the bottom becomes cut off. So if let's say I do a proper demonstration, maybe to see how it looks like. So I'll just make it 0 first. And then for your concrete, maybe just a copy on top of it. And as you can see, you will have this connection. Okay. So the next thing is maybe, let's say you have a cutout, need to provide a cutout for your slab. So since this one is a 3D, made from a 3D object, or still a 3D object, you can say that you can use the modeling here and then the extrude. And let's say, for example, I want to have a cutout from this portion up to somewhere maybe here, let's say, and a drop of 200. Oops, sorry, it's additional. So maybe I can just cut out again from here, point to point, and should be on the z-axis, and it should be negative, so it should be 200. So as you can see, you will have a cutout here, and it's still a precast. And let's say, for example, you also have opening, a small opening, maybe at the middle or somewhere. We can use also again this one and say a circle. So let's just say I will have to use this circle, or maybe I have to provide something. But maybe if, let's say, this box, I'll cut out just to have a shape. And as you can see, you can have your hole at the middle. Well, basically, because this one is a precast structural module, and we have placed the bars by ourselves, so definitely the software will not recognize if it will be cut or not. So in this case, you need to adjust by yourself according to the openings. So if you need to adjust some bars, then you have to do it manually by moving it. The next thing, let's say for example, you need to also put some fixtures. So you can easily put them by placing maybe the splice sleeve. And then say I'm going to place, okay, somewhere at this point and this point. Okay, so as you can see, it's inside your bars. Okay, and maybe we can place also the fixture for the lifting. So we can just place it somewhere here and maybe drop a little bit because the part is again. So let's put it here and drop. Oops, sorry. Okay. And then we can also adjust it from top to maybe about 200 z-axis. So from here, y negative 200. Oop. Make it more lower. So maybe and just say from here to here. It's actually there anyway. So that's how you're going to create your precast elements. If you have some other cutouts or openings, then you can just use the same procedure as what I did. We can also use another type of cutouts, a fixture, wherein you can use this also if let's say I have opening from here to here and the height of from here to here. So it's possible also that you can use this tool. So this one is called a modified precast element. You can move this, you can still move this in any place that you want it to be. So in compared to this one, it is already directly done using the 3D elements. So what you can do is still can do movement by stretching, but for this, for the other one, it's not possible to do. It's still possible to do by just moving and clicking this shape linear fixture, and you can place it anywhere. So basically, this is the basic or the workflow that you're going to do when you're going to use the structural precast elements. So after this, and let's say you have complied all the standards for the design of the column, you can now generate the shop drawing for this. So I have a shop drawing generated from this column with the corresponding bar shapes, as you can see from here. And as I can show you, you can modify the bars. Let's say you need to maybe crank a few. So maybe even if I put the reference here, as you can see, my shop drawing also changed. Okay. And as what I can do, maybe I just a little bit refresh. And as what you can see from here, I have added this bar wherein you have this bars bended. And if I show you the 3D, how it looks like, so it's something like this. So it's still possible to modify even you have created the shop drawing for it, and it automatically updates even if you're working with 2D to 3D or 3D to 2D. Okay, so that will be just a presentation for the structural precast elements. Now, since we opened up for the element plan, I will show you that in the matter of maybe few seconds for this number of precast. So I have different size, different shape, lengths with reinforcement and with not. So if I'm going to generate the precast elements for this, what I can do here, I will just show you how it's easy to generate it. So I will just go to shop drawing, and then hopefully you can see just okay, just to have it more clearer view. So if I go to my precast and I use this batch run, and I will just select this, and it's now exporting its element plan. And as you can see from your from your folder, it is actually automatically exporting each element. Okay, so it's done. I think it's about only 20 seconds. So if I'm going to show you maybe this one, so I'll show you some PDF. So it doesn't matter how big or how small your element or your shop drawing, PLANBAR is automatically giving you the option to find the proper or correct scale for your drawings. So another is maybe the longest one. Let's see what will be the even this one. So at the moment we don't have any reinforcements. You don't have the reinforcement here. So let's say for example we put some bars there. So we go back to PLANBAR, maximize this. So maybe we can have edit element for this and create. So maybe I can just create also the shop drawing so that it will be easier to see that everything that you're going to do from your 3D model or from your shop drawing is actually reflecting each other at the same time. So now you don't have the reinforcement. So let's try to put some reinforcement. So we're going to do the same. We can put some just a straight bar to represent. Maybe just a small bars of 10 diameter. Let's say the concrete covers maybe just say 25. And maybe we can place it here, somewhere here, and then place from the range of here to here, just to represent that there's a bar. And once you have placed that bar, okay, what you're going to do is just have to click on this and say refresh, and it will give you automatically your bar schedule here. Same as with the detail. So let's say, for example, I'm going to put a splice sleeve. So let's try to put the splice sleeve. So maybe this one, somewhere here, and it placed there. So I can say okay. And it automatically adopts the dimension. As you can see from there, it becomes 152. And we can update again the element plan. And you should have your detail coming out from there. Okay. So even if you move here, your fixture, even if you move from, maybe you can see from the model also. Let's make it an isometric view. And you can see it's whatever you put on your shop drawing, it automatically adopts your 3D model. So if I move it here, your dimension automatically follows. If I add a few more, so as you can see, the dimensions is actually adapting it. Okay. So this is actually the shows you how fast to generate the shop drawing of any kind of individual or shape or type of precast elements. So just to give you a background of a little bit of setting from, since we're talking about the element plan. So if we go to the catalog, and I can show you this setting, it is actually, I have created different layouts with a different scale. So basically, if you have different scales, then it will be the software will know what will be the proper or the correct layout or element plan for every single structural precast elements. So this is very easy for the program to recognize. As what I have shown you, when we export the shop drawing, it is actually about 20 seconds to export just these few elements, or maybe lesser. Okay. So that will end my topic for the structural precast elements. So if you have some questions, you can write on.
So, all right. So thank you, Jason, and
Thank you,
Mo,
Max.
for your wonderful presentation. So I think some of you has also been asking exactly how we are different from our competitors, for example, right? So my colleague has demonstrated how to create precast elements from scratch, and also all the way until shop drawings with you know, much easier compared to our competitors. So for us, PLANBAR is actually a BIM solution with extensive CAD capabilities, right? So you can see that we can work in 2Ds and 3Ds, but for, let's say, Revit or Tekla is mostly in 3D modeling. And it is actually quite, I think it is actually quite difficult to work in 2D because a lot of us are actually more used to working with AutoCAD, for example. So you draw lines in 2Ds. Then with PLANBAR, you can transform these lines into 3D models, and it actually works vice versa. Means you can, if you like, you can work in 3D, no problem. But if you want, you also can work in 2D, and we will generate the 3D models to your satisfaction. And actually, this results in shorter learning curve if you think about it, right? So I have a customer who is 60 years old. He is a director of a company, and when he saw our solution, he has some background in AutoCAD drafting. So when he saw our solution, he was thinking like, oh, I can actually learn it myself instead of asking my younger designers or drafters to learn a completely new software, right? And one key important advantage that we have is also in the shop drawing creation and alteration using our element plan technology. So Jason has also demonstrated how easy it is for 2D and 3D model to, to work together and come up with an accurate shop drawing. So you don't have to keep changing or keep altering your shop drawing catalog or even your presentation. The computer or the PLANBAR will automatically detect which one is the best layout for your precast element, and it will automatically show the details, the changes, the bar bending schedule, etc. All the full information needed for your shop drawing, accurate shop drawing. And we also stands for Open BIM, right? So we have the IFC for precast, and we are also part of the work group. And regarding machinery wise, because now we have Industry 4.0, so a lot of governments around the world are actually pushing for automation in precast factories. for example, right? So a lot of this production are actually moving to fully automated factories. And in Singapore, we have quite a few of these kind of factories popping up. And there is a significant demand for our software because I can say we are the only one in the market who can guarantee compatibility with this machinery production with our data. And lastly, which is I think most importantly as well, because we are a fully precast software designed by precasters for precasters. So for BIM to actually work, it's not just about a single software whereby you can design or do structural analysis, do rebar, for example. It is about the full precast workflow from conception to construction, right, to handing over to your developers, etc. All this has to be accounted for when you want to do a more efficient precast or effective precast workflow, right? So I have a few examples that I want to show you around the world. So in our headquarter country, Austria, we have this customer, Obendorfer. It's a huge company with producing over 1 million square of slabs, 1.6 million square of walls, and 1,100 precast structure parts every day. And they are using our PLANBAR solution worldwide. And they do have automated plants using mesh writing machine and 5-axis milling machines, for example, for this complex precast parts. And the performance of their designer has been phenomenal because they have been using our solution for many years, and we have been supporting their precast workflow as well. And as you can see from this number, 50 meters square per hour for precast shop drawing produced, including 3D models, shop drawings and reports, and also data for production in the automated plants. And another example is FDU, which has 27 plants across Europe. You can see from their maps, they are a huge company with so many precast plants around the European region or Germany region, and they produce 9 million square of slabs per year, 1.7 million square of walls per year. And I think they only employ like 1,000 employees in total to operate 27 of these plants, and including production, shop drawing, creation, etc. Right. So this is actually enabled by our TIM solution, which we will present to you tomorrow. It is a integrated platform, right? So compared to our competitor, this is actually a live case. So we have 2 factories by different owners, but all the machines, they are exactly the same layout, almost the same size, producing the same precast parts. But using our software, they can actually achieve maximum production within a short period of 4 to 6 months time, including training, configurations, etc. Right. So we have more than 700 precast customers worldwide, and altogether they deploys about 10,000 workstations, producing 230 million square of precast parts per year, and they spread across the world. In Singapore, we have Robin Village, Greyform, right? And in Indonesia, we have some customers as well, GPU, Indopura, etc. And we have a very strong foothold in Thailand as well, and also across the world, in China, in Europe, and also in America. So today's crowd is a little bit special because we have a huge, quite a sizable audience size from the students from universities, very reputable universities in Indonesia. So we are glad that you are here with us as well. So with the skill set in PLANBAR or Plan, you can actually use it to, for easier employment, for example, right? It is actually quite in demand at this point of time. And maybe a short sneak preview for tomorrow, right? So today we explained the precast workflow, But tomorrow we will show you more on the reporting, how you can report. And this is very important if you work in a company whereby you want to have accurate invoice generation, for example, and you want to create these reports so that your management can see like what kind of how much concrete or how much rebar you are using for this project, for example. And we will also be talking about this team platform that I've been talking about, Technical Information and Integration Manager. It's a model-based work preparation platform, and with cross-platform integration possible as well, including mobile information management. Right. So for now, we have some questions, or actually a lot of questions coming in from our audience here, and we appreciate your kind response. And so for the first question that we have is actually about lifting hangers. I think, and the second question is actually about parametric object. So let me just pass the screen to my colleague, and he will show you how it can actually be done. Right. And one more thing is that because we have so many questions coming in, so if your question is not actually answered for now, we apologize for that, and we will answer it after the session, and we'll give you a satisfied answer right after the session, because we cannot accommodate all these questions coming, and we'll apologize for that. Yeah. Siren, please.
Thank you, Max. Okay. Regarding to your question number one is a lifting angle. So just to show you what happened when we, let's say, make some changes or modification on precast work model. So now you can see there are lifting anchor at the top of the wall. It's normally actually, but lifting anchor you can get automatic lifting anchor according to your CG, according to your center of gravity. So what happened if, let's say, I make some modification on my precast wall? I create opening here, and now you can see the system will, let's say, we reposition your anchor or your lifting anchor. If I undo and redo, now you can get the result. Okay. Or even I create, or let's say I have the create merging from here to here. Wait, not here. Okay, again. Okay, I think because of, okay, I understood why. Unit, I have to resign. Okay. Okay, focus on this element. Okay, if I, let's say, design, you can see what happened. The system will automatically reposition of your lifting anchor according to your CG. Okay.
Sorry, may I jump in short in? Here you have seen exactly what's happened before. If the 3D walls is connecting together, there is a very strictly control that you cannot even extend it. That is very important. It's just to mention it.
Yeah, thank you, Yusuf. Yeah, because the wall is connected together, and you have no possibility to, let's say, to add or merging the new wall into the existing elements because of the clash between two walls. Okay. And the second question is a parametrics object. So, okay, we have Python path, we have smart path. But if you expect to have a parametric object from PLANBAR, we also have parametric object for 3D elements. Let's say, for example, if I create one box here, and with the block, when I click on that, you can see now there is a temporary dimension. With the temporary dimension, you just key in new dimension, new size of your width, length, or height of your objects, whatever you want. And of course, you can easily handle it as well. Depends on you. You can change options if you want to resize by scale or resize by point. Depends on you. Okay. And then for the crash check, actually we have a plugin. We say that it's a all check. With all check, you can check any objects, any items in the 3D modeling. You can see on the screen now. You can check architecture element with engineering, with precast, with reinforcement, with anything that you want to check. But in this video, we show you, let's say, how to use a Loo editor. With the Loo editor, you have to define object 1 and object 2 to check what happens. And of course, you can define color and gap between elements or the Loo. And then now you have the report or result of the checking on each object with clash together. We'll show you a small box or small highlight. You can decide by your own, okay, to fix this clash or not. But we also have the feature that you can use to check clash between elements. And this module, this add-on is free of charge. You can download by your own, install and use it without any cost. It's for the clash check. And for the other question, if we want to have bend bar for some area of your slab. Let's say, for example, I need to have bend bar for 1, 2, or let's say 3 bars from this side. So how can I do? I just make the support separation, and then go to bend bar 25 centimeter and okay, and now we get bend bar. Oh, sorry, I made 4 bars to have bend bar. Okay, you can move it. Sorry. Okay, if you want to, yeah, you can delete and create new ones again, but okay, I will not create it again. I just show you what happened after I delete it. Okay, so you can have some bar to bend if you want to have on each side of your slab or even wall. Okay, that's all from my side for Q&A. Next.
Yes. Oh, all right.
Can you please
All right.
take over?
So yes. All right. So due to the time limit, we apologize for, we can only answer so much questions now, but if you have any questions more afterwards, you can definitely contact us directly and we will answer to you, right? So before we proceed, let me just share my screen.